So the final section of what is the most complex part of the whole course, higher level programming, is applications. The first two we've pretty well done. Define the term dynamic data structure. A dynamic data structure is one that can grow, basically. So arrays cannot grow. Lists can grow. Trees can grow. They are dynamic. 19. Compare the use of static and dynamic structures. Well, I guess the slight difference, define the term dynamic and structure. Dynamic means it can grow. Compare the use of static and dynamic structures. It's the same old thing that with dynamic structures we don't waste memory. With static structures we potentially do. Although it is fine, this is a good thing to note, that if you have a structure that is X number of elements, and it's always X number of elements, then use an array, because you know it's not going to grow. But finally, though, this is important for the dossier aimed part of this. Suggest a suitable structure for a given situation. And that's where, going back to here, the techniques are adequate for the task and their use is explained. So if you just randomly throw in a queue, or randomly throw in a stack, or randomly throw in a tree without it making sense to throw in, then you're not going to get your 12 out of 12 here. You should use a queue or a stack or a tree or an array when it is appropriate. So, suggest suitable structures for a given situation. I got an example question there. You do, I already said, use a static structure when you know exactly how many elements you'll be working with, or it's really small. I mean, there's almost no use using the overhead of array list or linked list or making your own binary tree if you've got 100 elements. If you've got 100 elements for a computer, your computer's not going to have a problem if 99 of those are empty. So there you go. Those are the two times to use an array. So use an array. Be happy using an array for small groups. But dynamic, when the size of the structure is either unknown or variable, and you need to conserve memory. So if you were programming for a watch, a smartwatch, or a microprocessor inside of a refrigerator, then you're not going to have a whole lot of memory to waste. So yeah, in that case, you probably should use these dynamic structures. And list versus a tree, it's all a matter of whether you're going to be searching it. So if you have memory worries, you don't want to take up a whole lot of RAM, you're going to use either a list or a tree, then you're going to use a tree if there's going to be searching involved, and you want the searching to be faster. If you don't care how long the searching takes, then use a list if you want. But if you care about the speed with which your data structure can be searched, and you want it to be dynamic, then you'd use a tree. And that brings up the last point, that if you had a structure that had a set number of elements, there was for sure going to be a million elements, never much more, never much less, but you wanted to search it quickly, then use an array. But if those million elements could be 2 million elements, or could be 500,000 elements, then you want to turn it into a tree, because then you can add to it, take away from it, so it's dynamic, yet at the same time you can binarily search it. And that's why trees are so great. I think the bell just chimed, so that is it.